What's poppin', dogs? Mr. Allen here, evaluating some limits that approach both positive and negative infinity in this video. This first one, I'm going to start up at the top right. We've got the limit as x approaches infinity, positive infinity, of 5x squared plus 6x minus 2 over 3x squared. So we want to know what's happening as I plug in larger and larger and larger numbers. But ain't nobody got time for that, man. I can't just keep plugging in larger numbers. Perhaps there's a better way. So this right here, let's just say I had a function that equaled this, right? That's a rational function. So what happens at the far right-hand side or far left-hand side of my rational functions? Well, they approach either a horizontal or oblique asymptote. So does this? Which one does this one have? Well, now we got to think back, because there's a lot going on here. I got to think back to how do I get my horizontal or oblique asymptotes with rational functions? If my degree in my numerator is smaller than the degree in my denominator, that denominator is going to overpower it, becoming larger and larger and larger, thus approaching 0. But this one, my degrees are the same. The highest degrees are the same. These two terms here are essentially insignificant, right? When we're talking about going to infinity, okay? The 6x and that minus 2, they're not going to do anything compared to the numbers that are getting squared, okay? They're going to get way bigger. All right, so we're just focusing on these two. So if x keeps getting infinitely larger and x keeps getting infinitely larger, the x squareds and x squareds, they're going to like cancel each other out in a way, right? If I had 5x squared over 3x squared. If I have a million squared over a million squared, that's just going to cancel out, right? A billion squared over a billion squared is going to cancel it out. And I'm just left with the 5/3. So the limit as x approaches infinity here of all of this is just going to be 5/3. Boom. That's it. It's beautiful. Horizontal asymptote, that's key. I think the hardest thing with these limits is remembering all those old characteristics of different functions, okay? So this one down here, the limit as x approaches negative infinity, okay? Well, let's think back to our rational functions, right? I've got a smaller degree over a larger degree. So as I plug in larger and larger numbers, whether they're negative or they're positive, this guy's going to get infinitely larger than the numerator here, overpower it. So I'm going to have, if I plugged in a million, of 6 million minus 5 over a million squared. Or even it was negative 6 million minus 5, so negative 6 million 5, over negative million squared, that guy's going to get way bigger, right? And then a billion, so on and so forth. So I'll have a small number divided by an infinitely larger number, thus we will be approaching 0, which is my horizontal asymptote. Horizontal asymptote of y equals 0. All right? Cool. Awesome. Now this one. Interesting. Yes? And I have two examples that are the same thing here, but one's approaching infinity, one's approaching negative infinity. I wonder why I did that. Well, you're going to have to stay tuned to find out, kids. Okay, let's do it. So with this one here, give myself a little room. I have x squared over, or do I really have x squared? No. Really, when we're talking about, because this is not going to look like, this is going to look like illegal algebra here. I don't care about this guy right here. Does not matter to me. Okay? The larger degree here, the 9x squared, is the important one. What's the square root of 9x squared? Well, it's going to be 3x, right? Over 2x. So when I'm talking about limits here, I can think about that aspect of it because I'm just trying to plug in those larger and larger numbers, okay? And I can kind of do some sort of what it seems like illegal algebra here. Okay, so now as I plug this in, as I plug in larger and larger numbers, I can see that it's going to be 3 times a million over 2 times a million. That's just going to be 3 over 2. And whether I plug in a billion and a billion, same dealio, I'm going to get 3 over 2 for this one. So 3 over 2. But now let's look at the next one here, okay? The next one. Really, what we're looking at, okay, again, is that's insignificant, right? And I've got this square root of 9x squared, which we did say was like basically going to be like 3x over 2x. But we got to be careful here with this one because when I plug in, say, a really large negative number, it's getting squared, which makes it positive, right? Times that 9, square root it, all that good stuff. That makes it positive up here, no matter what. But when I plug in that really large negative number in the denominator, it's negative, okay? So this is an easy mistake to make when you're approaching negative infinity in this kind of situation. So you got to be really careful when you look at these things. So now for this one, I'm going to be approaching negative 3 over 2. Very interesting one there, right? So be careful, because I can't just say, oh, negative infinity, so negative, say, a million over, or negative 3 million over negative 2 million is positive. No, because in here it's squared, making it positive, square rooting it, but the denominator became negative here when we were approaching those negative numbers. That was a lot. Hopefully that makes sense. Okay, last one. I'll go with neon yellow. We have the limit as x approaches infinity of, we got a larger degree over a smaller degree. That means we're going to have a slant or oblique asymptote. So it's either going to be approaching, it's going to go up like this, or it's going to go down like this. It's going to be approaching positive or negative infinity. Okay, those are really our two scenarios here as we go to the right of this graph. How do we know which one it's going to be? Well, you could do some like testing of like sign charts, or like plugging in larger and larger numbers, see what happens. We can also maybe even just find our oblique asymptote. You don't necessarily have to do this, but I'm going to give you guys a little refresher here. We're going to do some long division. It's one of my favorite things in the entire world. Not really. No one really likes long division that much. But if I do go about the world of long division, we'll see what our oblique asymptote is. And then as we get larger and larger, we can make that decision. Is it approaching positive or negative infinity? So let's see here. 3x squared divided by x is just 3x. Multiply that down, we get 3x squared minus 3x. Draw them a line, change the sign. We've got to subtract them both. Those cancel, they always will. I'm off with x, drop down the 5, Snoop Dogg, drop it like it's hot. Now it's x divided by x is just positive 1. And then I'd have to multiply through. I really don't care about the rest of this here. I don't care about any remainder or anything like that. This right here is the equation, the y equals 3x plus 1. That's the equation of my oblique asymptote. So if I were to graph this, okay, if I were to graph it, I'd be up here at 1 with a slope of 3, and my oblique asymptote would look something like this. So it's going to follow along in some fashion, going up there into the top right of your graph and to the bottom left of your graph. So since we are approaching positive infinity, this is going to equal infinity. If I were approaching negative infinity, we know the graph is going to follow that asymptote down. Whether it's coming up like from here or down there, whatever, it's going to be going to infinity as we go to the right, negative infinity as we go to the left. Boom. All right, there's all of them there. I really think that this one right here is the trickiest, so really pay attention to that. I see those pop up all the time, and easy thing to miss there with that negative aspect of the 3/2. All right, hope that all helps you guys, and you have a wonderful, fantastic day. Thanks for watching.